Yeah, this is learning log number 4. On the front, we have the name, spring semester, in the class. We have the learning log paper here. It's supposed to be attached, and the table of contents. And we'll start with surface area. Okay. And lesson 13.4 is surface areas and polyhedra applications. Talks about what surface area is and nets and how you open it up and figure out how to multiply those areas, those numbers, and add them up to get the net area of a 3D object. And here are some examples that we did. Next was the surface area of a cylinder. Trying to figure out how to break it apart. You have to find a radius and multiply it by the height by 2. You have the lateral area and the surface area. Next, we have volume of a sphere, hemispheres. There's a little different. You have to do the volume. You did it by pi, but you did with the depending on the shape, it was a different fraction in front of it. And then we did a units conversions as well. Here are some examples. Volume applications, basically figuring out what the V stands for. When you find the volume of an area, you would do the B stands for whatever the equations represented. Like, for example, rectangle was base times height, or I'm sorry, length times width. And if it was a triangle connected, like in a pyramid, it would be 1/3 the base times the height. And you have a few problems down here with the conversion as well. Translations and rotations, using the line graph and figuring out how to translate the coordinates. If you was given a certain point, and if you added the x and the y, the x line, the x-axis, and the y for the y-axis. And he was giving some examples here in the rotations, whereas if it was on the line graph, the quadrants, it was by degrees, which was 90 was a quarter, 180 was half, 360 was all the way back around. Reflections were mirror reflections of coordinates, and if it was on the x-axis, it would be make the y negative, and if it was y-axis, you'll change the x to the negative. You would inverse it. Here are some examples here. Dilation and scale factors, and dilation is a transformation. Basically, if it would go from big to little, or from little to big, so it would be like if it was an enlargement or a reduction. And the scale factor was how much the difference was with the images. The back, we have the glossary. See, I ran out of some space on the front, so I had to put them on the back. It's got the page number on here. One of the new ones was coordinate plane. And some of the definitions we had. Like reflection, rotations, and some more for the surface area, translations, the x-axis, the y-axis. And pretty much it.